Hello friends, this is Hasiba. Welcome to today's session on problem on Cohen-Sutherland line clipping algorithm. So let us start with the problem. So the problem statement is as follows. Let ABCD be the rectangular window with A of 2020, B vertex is 9020, C 9070 and D 2070. Find the region codes for the endpoints and also use the Cohen-Sutherland algorithm to clip the line P1, P2 with P1 1030 and P2 8090. Right? So they have given the coordinates of the window and also they have asked us to clip the line with the two endpoints P1 and P2. So solution, first we have to plot the window. So what is the point A? Point A is 2020, right? So I have taken the point A as 2020. The second point B is 9020, right? So B is x-axis is 90, y is 20, right? So point B is 9020. Then the third point C is 9070, right? So x is 90 and y is 70. And the fourth point D is 2070, right? So first plot the points and make this clipping window, right? So we know that always the left hand side it will be x min y min, the right hand side is x max y max, the above point is x max y max and point D is x min y max. So once you have all the 4 points, so this forms our clipping window. Now they have given the end points for a line which has to be clipped. So the line is a 1030, right? So 10 is a little bit towards, if this is 20, right? So a little bit less than 20 it will be. So I have plotted the point 10 here, right? And it is 30. 30 means we have to increment 10 on the y-axis, right? So point P1 is 10 comma 30. So this is one point and one more point is 80 comma 90, right? So this is your line, right? So which is 70, right? So 90 means it will be little bit above, right? And it is 80, so it will be towards the left of your point B. So 80 comma 90, right? So we have to plot the points as they have given, right? So and again draw the line. So now the first step is we have to check whether this particular point is completely inside the clipping window or it is outside the clipping window or it is partial, right? So as we see how to find out that, right? So by Cohen-Sutherland line clipping algorithm, right? We know the region code for point P1. Point P1 is situated towards the left and it is towards the left of the clipping window, right? So if it is towards the left of the clipping window, the code will be 0001. That is, we follow the ABRL, right? So A stands for above, this is for below, this is right, and this is left, right? So ABRL method, right? So just refer the video where I have discussed about how to write the region code. So region code for the point, we write it by making use of ABRL method. So above, below, right, and left. Since the point is towards the left of the clipping window, so that bit will be set to 1. So 0001. Next, coming to the point P2. P2 is above the clipping window, right? So therefore, the region code for point P2 will be 1000, right? So as you can see, P1 is non-zero value, P2 is also non-zero value, right? So we have to perform the AND operation as per the algorithm. So P1 and P2, if I do, I will get 1 and 0 is 0, 0 and 0 is 0, 0 and 0 is 0, and 0 and 1 is 0, right? So when you perform the AND operation of two non-zero points and if the resultant value is 0, right? So then we say that that particular line is partial, right? So partial means it is not completely inside the clipping window, right? So half of the line is inside the clipping window and the remaining part of the line is outside the clipping window, right? So we have to display only that part of the line which is inside the clipping window, right? So to do that, we have to find out the intersection points, right? So this complete line P1 to P2 is intersecting at 2 points on the clipping window. So we have to find the intersection point I1 and intersection point I2, right? So then we will be displaying only the line which is inside the clipping window and the remaining part of the line which is outside will be deleted. So to start with, first we will find out the slope. So the slope formula is m is equal to y2 minus y1 divided by x2 minus x1, right? So our point P1, P2 is 10, 30 and 80, 90, right? Therefore, y2 minus y1 will be 90 minus 30 divided by 80 minus 10. So I will get the slope value as 0.857. Now, two points P1 are 10, 30, which is x1, y1, and P2 is 80, 90, which is x2, y2, right? So I have used this points x1, y1, x2, y2 in order to find the slope, right? So the first step is we have to find the first intersection point, right? So as we know that the first intersection point is towards the left of the clipping window, right? So when it is intersecting to the left of the clipping window, what will be your x value? X value will be same as x min, right? So because it is coinciding with the left hand side. So at the left hand side of the clipping window, x value is x min value, right? So we have to find out what is the y value, right? So in order to do that, so the first point will be x min comma y. So what is x minimum? So x minimum of the clipping window here is x min is 20, right? So x minimum will be 20 and we have to find out the y. So in order to find y, we have the formula y is equal to y1 plus m into x min minus x1, right? So y is equal to y1. So what is y1? Y1 is the point here which is 30. So 30 plus m is the slope which is 0.857 into x min value is 20 minus what is x1? X1 is 10, right? So you have to take this particular point. So whichever point you are taking here P1, so these values will be your x1 and y1. So your x min value will be the value of your clipping window, which is your 20, and you have to find y, right? So we are using the formula y is equal to y1 plus m into x min minus x1. So y1 is 30 plus slope we have calculated 0.857 into x min value is 20 minus 10. So 20 minus 10 is 10. So 10 into 0.857 plus 30, right? So I will get it as 38.57. So this is my y point. Y is equal to 38.57. Therefore, the first intersection point, which is x min comma y, will be 20 comma 38.57, which is nearly equal to I of 20 comma 38.5 is equivalent to 39, right? So I of 20 comma 39. So this is the first intersection point. Next, let's move on to find the second intersection point. So the second intersection point is that it is intersecting on the top of the clipping window, right? So this is our second intersection point, right? So here we have the y value, right? So which is y max, right? So we have to find the corresponding x. So to find the second intersection point I2, right? So we know that a y value is same as y max. So we have to find the corresponding x. Therefore, x comma y max. So which will be equal to I2 of x comma. What is the y max value here? The y max value is 70, right? So that will be equal to 20 comma. So it will be equal to I2 of x comma 70. So the formula is x is equal to 1 divided by m into y max minus y2 plus x2, right? So which will be equal to 1 divided by m value is the slope value, which is 0.857 into y max. So y max value is 70, right? So it is not 40 here. So y max value is 70. So 70 minus 90 plus x2 value. X2 value 70 minus y2 is 90 plus x2 is 80. So x2 y2 you have to consider, which is 80 comma 90. So just a small correction, make this as 70. So 70 minus 90, you will get it as minus 20 minus 20 plus 80, you will get it as 80 minus 20, which is nothing but 60. So 1 by 0.857 into 60, if you do, you will get the value as 56.67, right? So therefore the second intersection point will be 56.67 comma 70. So which is nearly equal to 56.67 is nearly equal to 57. So 57 comma 70. So now we have the clipping window here like this. So we have got the first intersection point as 20 comma 39 and second intersection point as 57 comma 70. So what we have to do, we have to clip the line which is outside the clipping window, right? So this P1 will be clipped till this intersection point I1 and P2 will be clipped till this intersection point I2. So the output what we get is a line which has the points 20 to 39 to 57 to 70, right? So this is our final output. So here are the different formulas which you have to use, right? So if you have the clipping window, if you are finding the left intersection point here, your y value will be same as your x min value, right? So x min or x max value, right? So it will be same as your x max value. So y will be equal to m into x max minus x1 plus y1, right? So here also y will be equal to m into x max minus x1 plus y1, right? So whatever is the value of x you have to take. So when you are coming to the to find the value here, to find the intersection point which is below and above, here the y value will be same as the value whichever is there, right? So you have to find the corresponding x value. So x will be equal to 1 by m into y min minus y1. Here it is x is equal to 1 by m into y max minus y1 plus x1, right? So this is x min, right? So change it as here when you are finding out the left intersection point, you will take it as x min, not x max. So y is equal to m into x min minus x1 plus y1. So here at the right hand side, you will take it as y is equal to m into x max minus x1 plus y1, right? So when you are taking the point intersection point which is below the clipping window, your y value will be y min. When you are taking the intersection point which is above the clipping window, your y value will be equal to y max. So this is how you have to solve the problem on Cohen-Sutherland line clipping algorithm, right? So sometimes they will directly give you the clipping window and they will give you the line. This diagram will be given. So directly you can go and find out the slope and the intersection points I1 and I2, right? So if at all they don't give you the clipping window, you have to take the points, whatever they have specified, right? So take these coordinate values and you have to draw the clipping window and also the line and then find out the intersection point and tell which part of the line will be displayed and which will be clipped, right? So first go through the video session on the explanation about Cohen-Sutherland line clipping algorithm, right? So then you will easily be able to understand the problem.